Hello, everybody. We are starting chapter 9, lesson 9.1. Here we start to get into testing claims, where we come up with more or less an analysis where we either confirm a hypothesis or we reject a hypothesis based on our results. Um, Tomorrow's a snow day. Well, as you watch this, it is a snow day. And I was going to shoot some free throws in front of the class for the lesson, but this will have to do. I was going to claim outrageously that I'm an 80% free throw shooter. Maybe I am, though. Who knows? To prove my skills, I was going to shoot 50 shots. We've done something like this in the past. But for now, to speed it up, I'm just going to say I made 32 of the 50 shots. Am I exaggerating about my skills? So number one, there's two possible explanations to why I only made 32 out of 50. Okay. The first explanation is that, that I am actually a good shooter. I am an 80% shooter. And this poor result, because 32 out of 50, we'll look into this, it's not really that good compared to my claim. This poor result happened purely by chance. Okay? And we call that the null hypothesis. Okay? The alternative hypothesis is that Mr. Feig is exaggerating his skills. Or, in other words, I'm wrong. I'm not an 80% shooter. I'm worse. Or better. Who knows? Okay? We have notation that's going to start to go with this. Oh, wow, I can't spell chance. Hello. Chance. So notation for the null is H sub 0, subscript 0 or subscript O. This is the null hypothesis that P equals 0.80 because I'm claiming to be an 80% free throw shooter, okay? Now, the alternative is a H for hypothesis with an A, subscript A for alternative. Oh, I shouldn't have an equals right there, folks. This should be, what is my, if I colon there. The null is that P is 0.80. The alternative is that P is not 0.80. 32 out of 50, by the way, is, if you divide that, that is 0.64. So I only got 64%. Okay. That's less than 80%. So I'm not going to be specific. I'm not going to say the alternative is that I'm exactly a 64% shooter. That's not what I'm going to say. I'm going to say that the truth is actually just less than 80%. My sample was lower, so I'm going to say less than. Okay. The population would be all free throws that I've ever taken. Okay. All free throws shot by Mr. Feig. The sample would be the 50 free throws that I was going to take in class, but wasn't able to. The parameters, what am I trying to measure? This is P. This is the true proportion of free throws that I make. True proportion of FT for free throw of free throws made. The statistic came from my sample. This is my statistic right there. And statistics are P hats. So that is 32 out of 50, which is only 64%. Okay, so again, the null is that I'm claiming 80%, and this poor result only happened just by chance. I had a bad day. The alternative is that, nope, the truth is actually that I'm not as good as 80%. I'm exaggerating my skill. So, to test this, we're going to assume explanation number one. We're going to assume this is true. And the language for that is we are going to assume the null hypothesis is true, which again is that p equals 0.80. We're going to assume that is true. And we're going to examine the likelihood of making only 32 out of 50 shots through a simulation. So again, if we were in school, I was going to have a spinner for you. In fact, I found one online that you can do. And I was going to have you simulate 50 free throws shot by an 80% free throw shooter. And you would spin the spinner 50 times. So I found this website called wheeldecide.com. It's really quite slick. You could do this yourself. Go there right now. And you just change your inputs down here on the bottom. I made the inputs make, miss. So I have 4 makes and 1 miss because 4 out of 5 is 80%. And then anytime I hit this spinner, it will, give me a result. Oh, look, I missed that one. And I was going to have us in class, all of you do this twice. Yes, I was going to have you hit the spinner 50 times to simulate me taking 50 free throws. Oh, there's a make, so I'm 1 for 2. Go again. There's another make, so I'm 2 for 3. I'm not going to bore you here and do this 50 times. We were going to do this as a class. Oop, another make. I'm 3 for 4 so far. And you would continue spinning and spinning 50 times, okay? You could do that for fun if you want and get your own sample results. And you would take your results and you were going to write it down here. Say that your first one, let's say you got 41 out of 50. I just made that up. That's 82%, so cool. Maybe you did it again a second time, spin it 50 times. This time you only got 37 out of 50, and that would be 74%. And we were going to take time. You were each going to have 1, 2 results. Then I was going to have you go to the board like we've done many times, and I was going to have you put your 2 dots. So 82%, you put your dot right there. 74%, you put your dot right there. And we were going to get the sampling distribution like we've done many times on the board. But since we can't do that because you're at home on a snow day, I copied and pasted this one kind of from a made-up answer key. It is based on this situation, though, an 80% shooter, okay? So according to this, we had this sampling distribution. Let's see if you can answer this. How many samples hit 80% exactly on the nose? Well, start counting. We have these. 1, 2, well, blue on blue, that's not a good idea. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 of these samples, remember each dot represents the result of a sample. These 9 samples hit 80% exactly. This sample here, they got 92% makes. Okay. That's what that means. Now, if I am an 80% shooter, right, what's the probability of getting this result by chance? So I can use this sampling distribution to help. The result of 64% or worse. Well, here's my 64%. I only have 1 dot right there, 1 dot. This whole thing was 60 dots total, okay? So what percent of the dots represent a proportion of 64 or less? It's just 1 dot, which is really low. If you change that to a percentage, that is 1.7%. So what does that mean? It means assuming that Mr. Feig is an 80% free throw shooter there is a, that's in my way, there is a 0.017 chance, not chance, let's say probability, of getting a sample proportion like we did. A sample proportion of 0.64 or lower by random chance alone. In a sample of 50 shots. Very wordy. But that's what we just did by theoretically simulating 60 different samples. How many of these samples were 0.64 or lower? Well, there was only one, but it covers anything from here and lower. Okay, so if I am an 80% shooter, this result only happens randomly, that which is 1.7% of the time. Okay, so based on that, does the observed p-hat of 0.64 give convincing evidence that I'm exaggerating? Or is it plausible or reasonable that an 80% shooter could have a performance this poor by chance alone? Okay, and I think you see where I'm going with this. I would say that Mr. Feig is exaggerating. I'm lying. I'm not telling the truth. I was a good basketball player. I was, but those days are behind me. And why? It's because the p-value is really small. So, here's some language for you. We reject the null hypothesis, which is h sub 0. Okay? We have convincing evidence that Mr. Feig is exaggerating or lying. Okay? Okay? Again, the p-value essentially is the probability, like I said right here. Assuming I'm an 80% free throw shooter, the p-value is the probability of getting a sample like we did. Okay? Here is the punchline, some of the summary of this, okay? Moving forward, you're going to start testing claims. You always have a null hypothesis. It might be a p, it might be a mu, depending on what we're doing. So h sub 0. The alternative is h sub a. We can do one-sided, meaning a less than or a greater than, or we can do a two-sided, which we'll talk about later. We did, up here, we did a one-sided, right? We did less than. Way back up here. Where was I? Way up here at the top. I'm exaggerating my skills. I'm a less than 80% shooter. Okay, so we did a one-sided test. Interpreting the p-value, here's another sentence frame for you. Assuming blank, there is a blank, okay, assuming the null hypothesis is true, then there's a, 5% chance, 2% chance of getting the result that we got purely by chance. We did this already right here, okay? So let's see here. Assuming Mr. Feig is an 80% shooter, that's the null hypothesis right there. There is a p-value. My p-value was right here. Okay? And then the last part is there is a sample, there is a 0.017 probability of getting a sample proportion of 0.04 or lower. That would be this. And it's the word, this one's lower. Sometimes it might be higher depending on if it's a less than or a greater than situation. Okay? So that's that sentence frame. We'll spend a lot of time on that. Your conclusion, because the p-value was so small, if the p-value is really small, we will reject the null. Okay? If the p-value is large, we will fail to reject the null hypothesis. We do not have enough evidence for the alternative, okay? So we're keeping it kind of general right now. You might be wondering, what is small and what is large? Like, we're going to quantify that as we go further. All right, cool. See if you can understand here, the check for understanding. Do people kiss the, quote, right way? This is a quick story that, I guess they study this thing. The San Gabriel Valley Tribune studies how people kiss, and it says most people are kissing the right way, meaning they tilt their heads to the right when they're kissing. Well, I don't know if I'd ever really thought about this, but I guess people study this sort of thing. I mean, I can tell you who my first kiss was. I can tell you where I was. I have no idea if I leaned to the right or to the left when we kissed. No clue. But yeah, I was late with my first kiss. It was I was a sophomore. She was a soccer player. She followed me down to a game in Rochester, one of my soccer games. And then we went to Dairy Queen afterwards. She got a chocolate dip cone. I got a chocolate chip, a cookie dough blizzard. I remember all of that. I have no idea if we leaned to the right or to the left when we kissed. But anyway, so my first kiss was at a Dairy Queen in Rochester, in case you cared to know. Anyway, it says they observed a random sample of 124 kissing couples and found that this percentage of them tilted to the right. Maybe this has to do with right-handed, left-handed. I have no idea. Do these data provide convincing evidence that more than 50% of kissing couples prefer to tilt their heads to the right? Okay. All right. So, number one is just what is the appropriate hypotheses, both of them, the null and the alternative, for this? Okay. So, the null is we have no basis for anything. So, we're going to say, well, I'd say it's 50-50. Okay, I'd say 50% of the time people tilt left and 50% of the time they tilt right. The alternative would be, now you have to look at the results of the study. Here's the results. I got a number that was larger than 50%, so I'm going to go with this one. I'm going to go with the greater than one. So that the true proportion is greater than 50. Do not put 0.669 right here. A lot of kids would like to do that. They'll say, it must be exactly 0.669. Don't do that, okay? Because that's too specific. That just is the result of one sample. It says also to define the parameter, okay? What is P? This is the proportion of couples who tilt their heads to the right when they kiss. Okay. Okay, explain why the data give evidence that more than 50% of the couples prefer to tilt their head to the right. This is simply because our p hat, because p hat is 0.669, which is greater than 0.50. Okay? In other words, our sample was much higher than 50%, than 0.50. So that's why we have some evidence, okay? Then number 3 says the p-value for the test was 0.0001. Interpret the p-value. So that's this sentence right here, okay? In fact, you could pause the video before you go see. I've already copied and pasted my answer down there. Can you fill this in right now, okay? Assuming the null hypothesis, assuming 50% of the couples tilt their head to the right when kissing. There is a, put the p-value there that I gave you, 0.0001 probability of getting a p-hat of, what was our p-hat? 0.669 or higher by chance. So there it is here, right? I'll highlight again some of these things. The null hypothesis is that right here, 0.50. Oh, here, let me try to keep the color coding the same as higher up. It's orange higher up, so there's your null hypothesis. The truth is 50%, okay? Then in bright pink, I highlighted the p-value. The p-value was just given to you, you guys. We'll dig into this a little bit more. The p-value comes from, guess what? A z-score and finding the probability in the green packet. And then the last color I did up here was green, just to keep things the same. Then the probability of getting 0.669 or greater, okay, that's that part. So put it all together, right? Assuming that the proportion of all couples that tilt their heads to the right is 50-50, then there's pretty much a 0% chance, a 0 probability of getting a sample proportion of 0.669 or greater by chance alone. So in other words, the random probability of this happening is practically 0. So what conclusion can we make? We can say, well, I'm going to reject the H null. So since p-value is so small, I will reject the null hypothesis. The null was that people tilt to the right half the time. And then I would say, well, in favor of what? We have convincing evidence. In this case, it's very convincing because p is so low. What do we have evidence of? We have evidence of, so we are rejecting this in favor of this. Okay? So we need to put this into words. We have convincing evidence that more than 50% of couples tilt their heads to the right when they kiss. When they smooch. All right. All very kind of general today, right? We'll dig into how to get p-values later. Today, just really, can you set up and define your null and your alternative? Do you know how to interpret a p-value if I just give you the p-value? All right, folks. Bye-bye.